This meeting is being recorded.
In section 9.4, we're going to look at how to prepare alkynes, and we'll see that similarly to alkynes and alkenes reacting similarly, also their preparation is very similar. So our first reaction we see here is an alkyl halide, so one halogen, that reacts with a strong base, and we see an elimination and double bond form. When we need two double bonds to form, we need a alkyl dihalide. So now we have two halogens, and we'll have two removals of HBr, and then we have our triple bond form. So we have what we see here, two subsequent eliminations, two E2 processes, until we reach our triple bond. So we have these eliminations that occur, and our starting materials we know need to be dihalides that include two halogens, and they can be either the geminal type or vicinal. So the difference between these is the orientation of halogens on the same carbon or on two carbons that are next to one another. So the geminal dihalide, I like to remember this because of Gemini being, the twins. So this carbon here has twin halogens, right? Two of the same thing, two groups on it. And then down here, these two carbons, they are next to one another, so they're in the vicinity of one another, but they do not have twin halogens, right? They're not on the same carbon. So we have geminal or vicinal dihalides that can be used to have this alkyne created through two elimination reactions. So we're going to take a look at how we prepare this in more detail here. We're going to use excess sodium amide, and that's what this is right here, NaNH2. We're going to use a reaction that's in equilibrium, and we're going to shift the equilibrium towards our elimination product. So we have here our dihalide, we have our sodium amide in our ammonia solvent. So we have first two eliminations that occur, and we get this alkyne here. But we have this shift in equilibrium that's driving this process, so it's hard to stop that process sometimes. So we usually end up with this alkynide ion at the end and sodium counter ions. So Na plus is our counter ion here. And then we use an aqueous workup such that hydrogen will protonate the alkynide ion. And we end up, right, with this equilibrium showing us a preference for our weaker acid, which is listed here. So the pKa of this acid is around 25, which is higher, so it's weaker than water. So water is an appropriate acid to use here. So again, we have a terminal alkyne. So we have this as our product here, and we can see the yield listed as about 60%. So when we treat our dihalide with excess, which is commonly abbreviated in parentheses or just using excess, like we see here, sodium amide in our ammonia, and then a water acid workup as our second step. So we have two steps here. The two eliminations occur simultaneously in the first step, and then deprotonation to form the alkynide ion, and then we have step 2, which has our acid workup, which protonates our terminal alkyne. So that's it for this section. We will continue with section 9.5 next time.